Hello everyone, and welcome you to our channel, the Stardust Stories, the Science of Meteorites. This is a channel that will try to explain you some of the basics regarding the terminology that we use in our science. We'll try to explain the terms of meteor, meteorite, meteor-wrong. So let's start with a meteor. Meteor, it's something that is coming from space, and you see a very nice illumination and light up in the sky. So a meteor is a body, is a small object, dust, rocky material that is passing through our Earth's atmosphere, and we see a nice illumination due to the very high speed that enters into the Earth's atmosphere on the average of 19 to 20 kilometers per second, more than 66 thousand kilometers per hour. And then this material is partly destroyed. That means it loses a lot of its mass. The mass is lost at the atmosphere, and about 70% of the material is disappeared. And then the remaining material is the one that we recover from the ground, from the ice, from the soil, from the ground in general. This material is what we called meteorite, and in several cases a meteorite can be really very difficult to be distinguished from terrestrial rocks. In that case is what we called as a meteor-wrong. So the meteorite is the material that's coming from space. The meteor-wrong is the material that has some properties that may be confused because its appearance maybe look like a meteorite. However, there are several evidences against the extraterrestrial origin, and this is the meteor-wrong. In this example here, we see a nice meteorite. This is a meteorite that is surrounded by the fusion crust. The fusion crust is the material that is formed from this nice trip, this nice passage through the Earth's atmosphere, and it's very thin, just a few tenths of microns, or even hundreds of microns, or even a millimeter. You see. Now, this is a meteorite, and we have cut a nice surface on this area here represents the interior of the meteorite. So we have originally have a rock, we cut it surface, and the interior of the meteorite has a different color compared to the exterior. The exterior is the fusion crust. The interior, in this particular case, is the material that is still preserved from the very early stages of our solar system. This is the original material. And it's important here to note that in this particular material there are several features, like this one. This is a metal, iron nickel metal, and then we have this nice line, the black material, which is called melt vein. So the melt vein is the product of an impact of an asteroid at the surface of the parent body from where this meteorite originates. And due to the very strong impact, the material is destroyed partly or even solely, and during that process melt is formed. The melt may formed in situ or travels through the cracks of the rocks and may fill these cracks. This is a scenario. In that case, the material that is solidified within the crack might be represent, as in this particular case, the melt vein. The melt vein is now composed by glassy material due to the very, very rapid growth, rapid crystallization, or rapid solidification of the original melt. But also there are some small crystals embedded within the ground mass of the melt vein. The small crystals might be formed from the crystallization of this melt, and also we still have some material from the ground mass of the meteorite, and this material could be original chondrule or part of the chondrule or some isolated minerals. Also within these melt veins may have some other minerals like iron, nickel, metal, like sulfides. There are also some chromites dispersed within the melt veins. However, the predominant materials are silicates, silicate minerals like olivines, like pyroxenes, or even plagioclase, and their high pressure equivalents. So it's likely, as in this particular meteorite represents the Hamada al-Hamra 346, and it is designated as L6 ordinary chondrite, composed by numerous high pressure polymers that are located within this melt vein. Another feature which is really important to note is, and which is a very diagnostic feature for this meteorite, is the presence of the magnetic properties of these materials, which are located at the surface of this meteorite, and these are see this magnet are iron, nickel, metal, or iron sulfides like the troilite. Another feature that could be important, other than the fusion crust, which is a very diagnostic feature, other than the presence of melt veins or even chondrules, like on this particular meteorite. So there are some chondrules like here, and the chondrules are remnants of the original material that has been formed 4.56 billion years ago. Other features are the regmaglypts, and in that case, if we see the exterior of the meteorite, we can see that it's like a fingerprints formed and surround this meteorite. These fingerprints are called regmaglypts due to the ablation of the solid material during the passage through the Earth's atmosphere, and the ablation of this mass left some curvy surfaces. Another feature which is not present here, and this is very diagnostic for meteorites, is the absence of pores. There are no holes. So, the absence of holes. So, if you see a meteorite, if you see a material, a rocky material, composed by numerous pores, numerous holes at the surface of it, then it is likely a volcanic rock or even scoria, which is a remnant of processing of the ore, of the material. And this is not diagnostic for meteorite. So if we want to summarize, We could start from the presence of fusion crust, especially for the materials which are a bit fresh. This is a meteorite that corresponds to a fall, and it is likely a very fresh material, and this is the reason the fusion crust is still preserved. The presence of melt veins, the presence of metal, the surface or the interior of this material, which is very magnetic. It's another possible diagnostic feature. It's not always the case. We might have some meteor wrongs or rocks from our Earth, terrestrial rocks, that are also a bit magnetic. However, it is very likely for a meteorite to be attracted by a magnet. The absence of pores, as I said, and another characteristic feature is the streak. So if you have a plate like the one that we put our food, and you get the material, the rocky material, the meteorite or a meteor wrong, if it left a color, red color, brown color, black color, when you try to scratch this plate, then probably it is likely not a meteorite. A meteorite, since it is mostly composed by silicate minerals, olivine, pyroxene, plagioclase, will never left any streak, any color by scratching our plate. This is for today. This is just a very short course on how to identify the basic features of a meteorite, how a meteorite looks like on a hand specimen, like the one we had before, the Hamada Alhambra 346. This is a really nice meteorite that we do some very nice research in our lab. We have found numerous high pressure polymers within the melt veins, high pressure polymers that are diagnostic for the impact processes that occurred at the parent body of this meteorite. Ioannis Basiotis, Associate Professor of Mineralogy and Petrology at the Agricultural University of Athens. Don't forget to subscribe, like our videos on YouTube, and hopefully I will see you again in the next video.